let us start this lecture with a thought process given by a rocket engineer Braun, and he says that the rocket will free man from his chains, the chains of gravity which will still tie him to this planet. It will open him the gates of heaven. Is it really true that what he says is right or wrong? That I will leave it to you, and let us recall what we discussed in the last lecture. And first we discuss about how this history of propulsion evolved, and during that time we learned three things which I would like to draw your attention. One is that engineering need not to wait for the science to evolve, so also the science. So, of course, they can complement each other. That is the one we should learn. The other thing you must learn that this aerospace propulsion and also other technologies are being driven by the war mongering people, which must not be done for the development. The third aspect one has to remember that what I am emphasizing, the sensitivity of individual for the plight of the people and mankind is very essential for developing any new technology that will be congruent with the all the ecological needs, requirements, and also the human being needs. So, with this we moved into the various classes of the aerospace propulsive devices. We broadly divide in two categories. One is air breathing engine, other is non-air breathing engines. Under the class of air breathing engine, in which air will be taken to be reacting with the chemical fuels for producing a thrust power. Under that categories, we have discussed about turbojet, turbofan and turboprop engine, apart from the piston engine, which is being used profusely even today from the starting of the aircraft engine or the aircraft propulsive device. And beside this, we have discussed also about what you call the non-air breathing engines, in which category we concentrate on the rocket or the chemical rocket engines. And it is I have classified into broadly into three categories. One is solid propellant rocket engine, other is liquid propellant rocket engine, and combination of both solid and propellant, what we call it as a hybrid rocket engines. Today, what we will be discussing is basically about how we can combine this air breathing and non-air breathing engines, and I will give you a very what you call glimpse about it, bird's eye view about that, and then we will move into the non-chemical rocket engines. If you look at, this is a ramjet engine which I have shown here. In this case, it is not having any rotary components. This is having a air intake here, and this is your combustion chamber, and this is a nozzle. And if you look at the air, will be entering at a very high speed. The M stands for Mach number, that means it should be greater than 1, and it will enter and decelerated in the air intake, and then you will have to have a fuel which is injected into it, such that you can have a combustion in the subsonic regime, and then it will be expanded in nozzle to have a thrust. And it is having several advantages over the other turbojet engine categories, because it is not having what you call it is not having any rotary parts, and it is quite lighter as compared to others, like, and it is having higher efficiency, and speeds of course limited only by the temperature and pressure of the engine that can handle. That means, material problem can be avoided, but it is having disadvantage that it cannot start of its own, right. particularly in the initial takeoff thrust it cannot provide. So, therefore, that is the big problem which you as you go along will see how it can be solved, and this is being used in the missile system as of now. And there is another exotic engine which has come up, is known as Scramjet engines. Unlike in the ramjet engines, here the combustion will be taking place in the supersonic mode. And keep in mind that this is a quite exotic and interesting engine, which people are trying from the starting from 1950s till date. However, with a very limited success, and India is having a program of a very ambitious program of developing scramjet engines. Lot of money has been pumped into it. Two organizations, particularly DRDL and VSSC, are working on this moment at this moment on this concept development engines, and it is having several application apart from the air breathing engine, apart from the missile application. It can have a what you call terrestrial application as well, particularly whenever the vehicle will be moving in the atmospheric region. So, let us look at a schematic of that. If you look at your air intake region will be starting from here, it is a quite high, because the flow will be at a very high speed. It is a basically hypersonic vehicle for which it can be used, and therefore, the fluid or the flow has to be decelerated, but however, you cannot really decelerate to subsonic, because if you decelerate to a higher to the lower velocity from the very high velocity, then naturally there will be ionization, and if ionization will occur, then you cannot really produce any thrust, rather you will have to, you cannot add any fuel to produce a thrust. So, in order to avoid that, this is being decelerated till the supersonic speed, and then in the combustion chamber in which the fuel is added, and of course, so that heat can be released in this case, which is quite difficult part, because the time requirement for the combustion to take place is quite small, and then it has to be ignited and also burned completely, such that efficiency will be higher. So, this is the challenging part, and beside this, flame stabilization is another very important aspect, which is being addressed at this moment with little success, or maybe to some extent they are successful in devising, but however, there is a lot more to be done in future. And it will be expanded, the hot gas will be expanded in a nozzle to produce a thrust. So, if you look at, one cannot really isolate the engine per se from the what you call body. Therefore, this is a propulsion airframe integrated scramjet engine. That means, the propulsion device must be integrated with the airframe properly, otherwise it will be not successful to have this flight. And it has been used in some of the recent what you call SR-71 Blackbird, with of course, varying degree of success, and in future people say that it will be having what you call lot of possibilities of developing a better systems, propulsive devices. And not only India, but there are several other countries like USA, Australia and other countries, they are working vehemently. But I am having a one question to ask you people, do we really need to have this engine, because it guzzles a large amount of money, and the material and other aspects are also has to be looked at it. So, particularly from the Indian perspective, whether we could look at it. Of course, a lot of young people are excited about this engine, because of our icon Dr. Abdul Kalam, who is a what you call icon for the students to follow that. and we should look at this aspect and see how it can be used for the common human being than that of winning a war or for a limited number of people. So, beside this we will be discussing about that how this engine concept, both the air breathing and non-air breathing can be combined together, because each class of engine is having their own advantages and disadvantages. Like if you look at a human being, each individual will be having certain good qualities and certain bad qualities, but when you combine together and work in a group, we try to maximize the good qualities, so that society or a system can run. Unfortunately, it is not happening in India, but that is the desirable, and it is more natural to be that. So, therefore, in the same process is being utilized while developing engineering system or component, that you combine, try to see whether you can optimize the what you call performance and optimize the process, so that you can get the maximum benefit out of it. So, there are several combination one can think of, like one of them what I have discussed is the ram rocket engines, and there might be also this is known as what you call combined cycles, rocket combined cycle engines and turbo combined cycles engines kind of thing. That means, in one class there will be rocket and the ramjet combinations, and in other case turbojets and ramjet combination. So, what we will be discussing about this ducted rocket engines. In this, generally rocket is being used to start with, right, wherever the initial thrust is required or take up thrust is required, which is disadvantageous for the ramjet engine. And then in this case, the rocket will be working on the reach condition, and you take some air from the atmosphere and then burn with the rich fuel, which will be remaining, and then you will be ejected out of that nozzle to get the thrust. And there are several class kind of thing. This is the basic idea that is known as ducted rocket engine, but there are several class kind of things like ejector rocket ramjet engines, and in this case it will be in the initial started with the ejector, and the rocket will be acting will be working till the Mach number 2, and after it reaches the Mach number 2, the ramjet will be taking over. So, this is known as ejector ramjet engines. Will be there are several other classes like integral rocket ramjet engines, air augmented liquid rocket engine, and ducted underwater rocket engine, which I will not be discussing. We will be discussing basically integral rocket ramjet engines, and in the next slide we will be discussing air augmented liquid engine. If you look at advantages, there are several of them. It is having lightweight, higher specific impulse, which we will be discussing and defining. You can say that it is having a better performance parameter, longer duration operation, because of like rocket engine, it can be operated for limited time, but whereas if you are breathing the air, and then it will be operated for longer time, and then higher payload capacity and higher thrust to weight ratio, which is a quite good as compared to the rocket or the solid propellant rocket engine, higher flight range and higher acceleration rate than the ramjet engine. And as I told you, it is having several advantages. Let us consider its disadvantages, component complexity and ejector rocket nozzle part kind of things. I will just let us look at what is this integral ram rocket jet engines. If you look at, it is having a what you call a ramjet fuel, which is having here, and it is to start with, it is having a solid propellant rocket engines having a separate nozzle. To start with, this rocket, solid propellant rocket, which will be fired, and then once it is high pressure and high temperature gas is being generated in this, it will be ejected through this nozzle, and you will get the thrust, initial thrust. But after that, once it reaches the Mach number of 2 kind of thing, then this whole rocket propellant or the grain the rocket engines along with the nozzle will be ejected out. That means, this is ejectable nozzle insert, which will be going ejected out, and then it will be taking the air and fuel, the ramjet fuel, and it will be working like a liquid propellant ramjet engines, and you can take a very longer path. So, it has been used in our BrahMos, the missile system, which being being developed by DRDO and Russian Federation, and beside this it has been used in Bloodhounds missiles in UK and several other places as well. So, let us look at the augmented air augmented liquid rocket engine. In this case, it will be similar in nature, but however, there is a little difference. There will be a rocket thrust chamber, which will be there, which is not being shown in this diagram, and you will take the air all the time, which will be continuously feeding to the start with, and then there is a liquid fuel injectors which will be working. That means, you need not to put this what to call eject that rocket engine, because it is a liquid fuel rocket engine itself, but to start with you will start with the rocket engine, because enough air may not be there to start with. After that, you will be going to the mode of ramjet engines. So, which we will be looking at basically turbo-ramjet engine. Why all these engines are coming into picture? Because of inability of ramjet engine to give a initial takeoff thrust, and in this case there is a turbojet which is having shown here, and to start with the air will be coming through the diffuser or the air end intake into the turbojet engine, and it will be having various component. As I told in the last lecture, I have shown you some pictures, that is having a compressor, and it will be having a combustion chamber which is not shown here, and turbine. Of course, there will be a gas. In this case, nozzle need not be there, it will be expanded in that other nozzle, and but in the this is basically bypass flaps which is there, allow the flow into the turbojet engines. This is, there is a bypass flap, and in the whenever you move into the regime where ramjet can be operated, you can put this turbojet off by putting this bypass flap, which can block the air not entering into turbojet. However, it will be entering into the ramjet components, and you will get the thrust. So, and the good thing is that you can always start the engine whenever you can. That means, it can be reusable, like you can land it and again take off, that is a good thing. But the bad thing about this turbo ramjet engine is that you will have to carry the weight of the turbojet along with you. So, sometimes you will have to find out what I mean, like what is the requirement, what is the mission requirement rather, and whether you can use or not, and it has been used by the for the missile applications and some other kind of things, other application as well. So, if you look at now, we will be moving into the non-chemical rocket engines, and before getting into that, what I told you that I have given you a bird's eye view of the new combined cycle engines, right, and it is several varieties are there, and you can look at it if you are interested in. But however, I will not be discussing now, we will be moving into the non-chemical rocket engines, in which case I will be discussing about nuclear power rocket engines, and then solar power rocket engines and electrical power rocket engine. I will be giving you a very short view or a small the bird's eye view of the whole concept, and then I will be moving into the other things and concentrating only on the chemical propulsive devices. So, if you look at this nuclear power rocket engines, why one has to go for a nuclear power rocket engines? Why not chemical propellants, which is being used from the time immemorial, can be utilized for the rocket propellant engine? Can anybody tell me?
Nuclear rockets have higher thrust to weight ratio compared to chemical rockets.
But why? What is the reason? Why higher thrust to weight ratio will be there? Because it is having a limitation. That means, the chemical rock propellants or the fuels is having limitation of energy being produced per unit mass of fuel. For example, for hydrocarbon, if I take ATF, that is aviation turbine fuel, which is nothing but a refined kerosene, right, and air if I burned, I will be getting the heating value will be 45 megajoule per kg, right. Whereas, if I use the uranium 235 and bombard it and such that nuclear fusion can take place, then the heating value will be 79 what you call 0.3 into 10 power to the 6 megajoule per kg. That means, you can use the higher amount of what you call energy for producing a higher thrust and higher other things. So, therefore, there is not much limitation. However, it is not that easy to use because of several problems associated with it. And you might be aware that recently in Japan, there was a catastrophic accident which caused a lot of damage to the people and environment as well. However, let us look at that nuclear power rocket engines can have a 3 kinds of reactors. One is your what you call fission reactors, and other is your radioactive isotope decay and fusion reactor. And in the fission reactor, what happens is that the nuclear will be of uranium 235 will be absorbed by a neutron, right, and as a result what will happen? So, what we are discussing about the fission reactor, and during the process of fission, what happens is that the uranium 235 will be absorbing a neutron, and when it absorbs, it will be having energy level will be increasing, and then it will be separated or splitted into 2 nuclear, one is krypton and other is barium, and it will be also generating a large amount of energy. Beside this, the gamma rays which contains a small amount of energy which will be generated. So, this kind of energy is basically due to the nuclear fission, because the nuclear being separated into 2 smaller what you call nucleus. And in the process also it creates 3 more neutrons, sometimes it is 2 also, need not to be 3, and these neutron become potential for to be absorbed by other uranium nuclei, such that this reaction will be continuing. If you look at in this figure I have shown here, it became a more number of kryptons and barium being generated, and more number of neutrons are being also produced. That means, each became potential, and this is a chain reaction. Now, if it will continue like that, then what will happen? It will be kind of a explosion or a bomb. It will be very difficult to contain it. So, therefore, whenever we are talking about this nuclear fission to be used for harnessing the energy, we need to contain or absorb these neutrons. That means, we control the what is the number of neutrons being generated, otherwise it will be beyond our control. So, it is very important to keep this in mind, and this is the one way of generating the large amount of heat as compared to the chemical rocket. It is a maybe 3-4 order of magnitude, as I told in the last Y34, it is a 6 times 6 order of magnitude than that of the chemical energy that can be liberated due to chemical reactions. And there is another process which is just opposite of that, where this deuterium nuclei will be combined with tritium nuclei, and as a result it will be generating a helium 4 and a alpha of course rays, and a neutron being generated in the process, and it gives 17.6 mega electron volt, and this is being being utilized. A large amount of heat or the energy can be generated, which can be utilized. Unfortunately, we are not very successful till now to do in a controlled manner, and most of the stars and then what you call like sun and others cosmic entities, they do involve this kind of nuclear fusion, which will be going on for several years. It is an infinite source of energy, almost to say so. And this energy can be utilized for the rocket propulsion, but unfortunately till now no work, or it is not successful even in civilian, forget about this application which is military and other planetary applications. So, and radioactive isotope decays, which is a very generally it happens, but it will not having much applications so far rocket engine is concerned. So, which will be I will be giving you only one example, that is solid core fusion reactors. The schematic is being shown here, and here you can use any other propellant like kind of thing, which will be having a good thermophysical properties of, or rather heat capacity to absorb the heat generated in these nuclear fusion reactors. And here hydrogen being used, and it is being pumped at a high pressure. It will go through the nozzle. You will look at outer casing of the nozzle and also the reactors. This is a typical which is being used in liquid propellant rocket engines. The hydrogen will be flowing through it, it will absorb some amount of heat, it will be converted into gas, and then it will be entering into the what you call the nuclear reactor core. And keep in mind that this is having a control rod, as I told you that we need to control this generation of neutrons. So, this will be controlling that, and this will be absorbing the heat. Of course, there is a reflector of cooling jacket and other things will be there to contain the reactions kind of things. And beside this, some of this hydrogen also used to run this turbine, otherwise you cannot have a pump. And after that, it is a typical chemical rocket engine kind of thing. This is a high pressure and high temperature hydrogen, which will be expanded in a nozzle, and you will get a thrust. So, if you look at very high thrust level around 40,000 Newton or 40 kilonewtons, even higher than that one can get easily, and temperature is restricted to the 2500 Kelvin. However, higher temperature one can use, provided better material is available, right. And high specific impulse you will be getting as compared to the chemical rocket engines, and ejection velocity you can get a very higher values. And we will be looking at the electrical power which can be used for producing a thrust. And of course, these engines is having a limitation of getting lower thrust. However, it can be utilized in space, particularly outer space, where thrust requirement is not really very much. And there are several ways one can think of: electrothermal and arc heating and electrostatic or the ion formations. And look at, I have taken only a electrothermal rocket engines, and where electrical energy is being utilized to generate some heat. You must be aware that heat can be generated by basically several means. one of the easier way is doing using a resistance, right. You can have inductance, you can have other way of generating the heat, converting electrical energy into it. In this case, what I have shown here, it is a basically heating coil, what we people use during the winter season to heat the room or our food preparation, other thing. It is as simple as that, but however, it has to be little more energy density. That means, the amount of energy released per unit surface area must be higher, because it must be compact one, and then you can use what you call the various propellants. Propellant can be hydrogen, it can be nitrogen, it can be hydrogen, it can be ammonia, it can be any other things, one can be use it, and even some cases you can use as well some kind of monopropellants, where it can be reacted and can release also energy. Of course, some of you may think of using, and there are several ideas one can think of using for augmenting the thrust in this case, but however, to have a voltage or the electric power, you need to provide various systems, like I can have a solar systems as such to produce some electricity. Nowadays, fuel cell is coming into pictures, maybe some people can use that, or you can use some kind of other energy like storage energy one can use, but problem is that it can only provide the very low thrust, is the 0.01 to 0.5 newtons, and you should not restrict about that, but there might be better ways of doing it, and temperature being limited to 1000 Kelvin, and one can go for little more, but the energy density requirement will be higher. And it is a usual rocket engines, where the high temperature gas and at a high pressure is expanded through a conversion diversion nozzle to produce the thrust. So, I mean, this is the basic thing about electrothermal kind of rocket engine. There are several varieties, we will not be really looking at all of them, but some of you are interested, you can look at it leisurely. So, let us look at arc heating rocket engines, and in this case arc is being used, having a in this schematic a annular cathode and anode is being used to produce a arc. And you know that arc can be produced when the high voltage will be across this cathode and anode will be there, and which will be creating a kind of a plasma as such, and because that will be broken out and a spark will be produced. Whenever spark is produced, very high temperature is being generated, because we know that in the case of simple electrical heating, the high temperature cannot be achieved. For that you need to give a very large amount of heat, but whereas here you can get a what you call high temperature very easily, and higher temperature higher will be the pressure, and also the it can be expanded and to get a higher thrust. And there are several varieties which I have can be one can think of, but in this case I have shown in a very simple one, the this having a working propellant or the fuel which you can use. Basically, it is a propellant, as I told it, any propellant can be used like hydrogen, helium and hydrogen kind of things, and it has to be pumped, so that you can have a higher pressure generated here, and it will be coming through that it will be acting like a medium for the spark to occur. That is very important, and it will be spark will be produced whenever the voltage, high voltage is being applied here, and it will be although the high temperature will be during the spark will be occurring, but the average bulk temperature has not really being increased, unless otherwise you go for a little better design, and what people have done till now is 1500 Kelvin, and when this will be expanded in a nozzle, you will get a little higher specific impulse as compared to the chemical rocket engines. So, this is one varieties of the what you call arc heating rocket engines, but there are several other varieties as well. So, which you can look at it in the literature, but let us now move into another varieties of engines which we will be discussing is electrostatic or ion rocket, and it will be different than what we have discussed. In this case, there will not be any rocket nozzle will be there. In other words, gas need not to be expanded in a nozzle to get the thrust. Rather, in this case the ionization will be used. That means, the gas will be ionized by stripping of electron. I have shown a what you call a flow chart kind of things, where you can see the working fluid or the propellant can be any gases like mercury, then what you call kryptons, argon, cesium and kind of gases, and which will be basically feed from the tank with the feed mechanism will be there, and you will use electrical power to ionize it, right. And then these ionized particles will be accelerated by the electrostatic forces. It can be electromagnetic forces you can apply, and when it is accelerated, you can accelerate to a very high velocities like 2000 to 60,000 meter per second, and generally the kind of velocities what is being used in practical system is around 25,000 to 32,000 meter per second, and you will get of course what you call a little lower thrust, but it is having no nozzle and it is a very compact and smaller systems, except you need to have a higher voltage sources. That is the kind of things, and which is being used by Russians in the outer space region for this electrostatic engines. Let me what you call look at the actual one, which will be like N star ion thrusters used in deep space. As I told that if you can, it is having a two components. One is your ionization sections, the other is your acceleration sections, right. If you look at what is being done here is that there is a cathode which is being used, it is having a higher voltage such that it can produce some electrons, and these electrons will be moving towards this chamber, where the xenon gas or any other propellant can be passing through this, and it is what you call there will be magnetic field along with the axial direction and also the radial direction, such that these electrons should be coming in contact with the what you call the propellants. Otherwise, you cannot really strip those neutral gases and generate an ion. So, therefore, this will be moving in a spiral manner, right. In a spiral manner it will be rotating. So, that all or most of the what you call these propellants molecules should come in contact with the electron to be stripped up, so that ion will be created. Once ion is created, it will be moving at a certain velocities. Of course, it will increase, but however, there is a acceleration grid which is created by the voltage. Like here in this design, it is 1065 volts and there is a negative also 180 grids volts are there. So, that it will not be going astray, and the objective of this grid is to impart a higher velocity, accelerate the velocity of the ions, and in a particular direction. That means, it should be not moving here and there. That means, the vectors or the direction of the velocities should be in axial direction. So, that is the two function of this kind of accelerator grid, which is you can say that it is as good as a your nozzle, it is working like a nozzle, but it is not having any physical kind of thing, and this is the gap between these two accelerator or the two grids. These accelerator grids is very small in order of kind of thing. So, that you need not to carry a very bigger what to call the nozzle to have a requisite thrust for getting good expansions and the optimum expansion. Apart from that, it is very important that there is a neutralized cathode, which must be producing some electrons, which will be absorbed by this thing. That means, the thrust which will be acting on this grid, right. The thrust will be, because of this movement, the thrust will be acting on this grid, and it will be transferred to the rocket chambers or the what you call thruster, ion thrusters. But after that, after the grid, you can have this neutralizing electrons, which will be combined, so that it will be neutral, and it is not having a detrimental effect on the thrust being produced by the rocket engines or the ion thruster. So, this is about what you call the electrical rocket engines. Now, we will move into the solar power rocket engines. When you talk about the solar power rocket engines, there are several kinds, right, but I will be discussing about solar thermal rocket engines. You might have seen in the satellites, there is a solar panels, right. You might have seen it is having a solar panels to give some energy, and that can be utilized to propel as well, right, because we have seen already the electrical rocket engines will be there, where you can use that either in any form, either in a ionization thruster or some other thing, particularly in the deep space. But those things are having limitations. What are those limitations? Because of efficiency of solar cells and panels are quite low. It will be around something 10 to 15, or some people are claiming it to be 20 kind of things, not more than that. So, therefore, there is a lot of challenge to improve that solar panel efficiency or solar absorption by the solar panels, solar cell efficiencies, and which will be beneficial for the land use as well, because in after maybe 100 years there will be hardly any fossil fuel to be left to be used. So, if some of you could take it as a motivation and do work on that and improve the efficiency of the solar cell, it will be a great boon, particularly to India, where we are having a large amount of solar energy available. So, but what I will be discussing about the thermal solar rocket engines, which is being shown here, and it is having similar to that of like is a gas, rather gas cannot be used because they having limitation. You can use also the liquid fuel, particularly liquid hydrogen. Then when you talk about liquid hydrogen, you need to have a cryogenic, that is another problem. But however, if you go to the deep, very deep space, maybe you will overcome that problem. But then this gas tank, you can have this thing, it will go to a parabolic reflectors. It can be, there are several reflectors, like which can collect this solar radiation, and then in this example I have taken as a parabolic reflector, which will reflect this solar radiation and put into this kind of heat receivers or exchanger, and in which there will be exchange of heat will be taking place between the propellant and this tank, and then as a result there will be increase in pressure and temperature, right, particularly temperatures, and then it will be expanded in a nozzle, and keep in mind that the temperature of course is limited to 2300 Kelvin, and that depends upon your panel design, also the parabolic reflector design, and also the heat exchanger design and material, also the rocket engine materials. And of course, the ejection velocity is limited to low velocity, because it is similar to that your chemical rocket engines, unlike your ion thruster or electrical engines. So, this is being very rarely being used, however, a lot of research is going on to have this compatible. And so, if you look at the applications of the rocket engine are having several. I have just jotted down here some of them, like space launch vehicles, which all of us know that we are having a space launch satellite launching particularly vehicle known as PSLV, GSLV kind of things. And spacecraft, of course, it is being used by Apollo and other engines. And the most places where rocket being used, or all the development, I always feel is being motivated for winning a war, that is a missile. But I feel that war we should avoid. Actually, I always feel that war lies in the mind of the people, must be removed, so that we can have a peaceful existence in the world. And beside this, a lot of research, airplanes, it is being used, rocket engines might be knowing for the conducting research, like your recently the Scramjet engines, it was being fired from an aircraft, very big huge aircraft. You might be looking at in videos, nowadays it is available in YouTube. So, the ejection of Q escape capsules, that is for which the rocket engine can be used. And of course, a propulsion belts, like if you look at one who was a Chinese fellow, lost his life kind of thing for making a rocket sled. Similar thing people are talking about, even some companies has come up to have a field the gravity, zero gravity effect, and some other things you can have a propulsible. This is the imagination of the human being will propel how you can use a concept for the for use. So, beside this the propulsion for target drone, again it is for the of course, military application, but you can use for some other applications as well, civilian applications, but generally it is used for the military applications. So, like signal rockets, we want to give some signals and other things that can be used. But there is a good application about where we need to work for rocket engine. Sometimes I feel, why should I teach a rocket engine which is not good for the mankind. But however, whenever I come to these sounding rocket engines, that is quite good, because you can talk about this atmospheric measurements and weather forecasting and other thing, it can be used, that sounding rocket. And there is a vernier rocket where you want to have some kind of course corrections and other things you can use, and the spin rocket where you can use try to spin something and then you can use it for some other purpose, and throwing lifelines to the ship. This is a very important applications, I feel, from the civilian point. So, for example, there is a storm in the sea and two ships are there and they want to interact, they want to supply the food or something exchange. You can use a rocket engine to have connect the lifelines between the two big ships, which you cannot really move in a very adverse conditions. So, these kind of things one can think of using applications of rocket. As I told you, engines depends on the imagination of people, and once your mind is being more benign and then more humanistic, you can find more application for rocket engines. With this, I will stop over, and in the next lecture we will be discussing about the various fundamental aspect which is required for the rocket engines. Right? Do you have any question to be asked?
Possible to means nuclear rocket, we are using the nuclear energy to heat hydrogen and converting it to and accelerating it. Is it possible to directly convert the thermal energy to accelerate the rocket?
Thermal energy you can, how you can do that, like you were saying as a electron, basically what it gives a large amount of thermal energy. So, whenever it is there you can use that itself to basically to expand it in a nozzle, right. Do you have any other idea by which one can do that? Thermal is the only one way of doing it. It is not like your ion thrusters, of course, there is a plasma thruster which I did not discuss, right. So, what is the coming into picture my mind is the only the thermal is the way. Of course, there might be several other means of doing that, but I think I am not aware of it. Okay. Right. Any other questions? So, if you do not have any questions, we can stop over here. Okay.